Okay, hi guys. In this lecture, we'll be continuing on seeing some more examples on the elimination reaction. I hope you are enjoying the process. Okay, so let's say we have this example wherein we have this compound. This actually undergoes reaction with Br2 in presence of CCl4 to form product A, which becomes the substrate for this reaction. 3 moles of NaNH2 are passed to form product B, and again ETI is passed on product B to form product C. Okay, so if we look at it, we get something like this, wherein we get PS2, this one reacted with Br2, it will be a I hope you remember, it will be a anti-addition. Okay, we will get something like this. Okay, it can be downwards also. Okay, so then next 3 moles of NaNH2 is acting on it. Okay, so what we'll be getting is double bond CH2Br is removed from 1 mole. From the second mole we have something like this removed. This is CHBr then. Okay, so in the next stage, in the third mole of NaNH2, we will have something like C minus and Na plus here. So this would be this is the A product, this is the B product, and in B product we have something like ETI taking over. So we would have something like this as the final product. Okay, so this is the final product of the series of reactions. Okay, let's look at another example wherein we have something like this. And CS3 here. Again we have something, we require X as the answer. X mole of NaNH2 is required here. Okay, to form a product A, which reacts with my Y moles of CS3I to form final product as something like this. C and CH3. Okay, so you have to identify values of X, A, Y. Okay, so how can we approach this problem? Obviously for this 2 moles of NaNH2 is required to convert this product into, for 2 moles of NaNH2 are required to convert this product into something like this. Okay, then we need another 2 moles of NaNH2 to convert the same product into this. Okay, we need another 2 mole of NaNH2 for this, removing these hydrogen atoms here, from here and from here. Okay, so we would have something like C minus Na plus here, C minus Na plus here. Okay, so total X value comes out to be 6, and this is the product A. Okay, now this undergoes Y moles of CH3I to produce a product B, which is CH3 C triple bond C. Okay, so if you can closely see, this structure remains the same. So 2 CH3 are introduced at 2 positions of C minus. 2 positions of C minus. Okay, so Y value would be 2. So the answer is X is 6, Y is 2. Okay, so now let's actually look at another example where we have something like this. Double bond O and again double bond O. Okay, so this reacts with X moles of PCl5 to form a product, and the product actually reacts with Y moles of NaNH2 to form a product, and which actually reacts with Z moles of CS3I to form something like this. So you have to determine the value of X, Y and Z. This is the final product. Okay, so obviously we need for cleavage across this bond and this bond we need 2 moles of PCl5. This product form would be something like this, wherein we'll be having 2 Cl attached here, and similarly we have 2 Cl here. So X is 2. This is the product. Then reacting with Y mole of NaNH2, obviously we require 3 plus 3 6 here. Why? 2 for 4 for this, and 2 more for creating a negative charge O on this carbon atom. So the product Y would be, we need 6 moles, and the product we formed would be something like C minus Na plus. Similarly, replicating here also C minus Na plus. Okay, and it reacts with 2 moles of CS3A to form finally this product. Okay, so I hope you are clear with this example and you had a fun solving this. Okay, let us look at another example where we have something like this. This undergoes first NaNH2 reaction with NaNH2 and second with ETI to get converted into something like this, where we have CS3, C double bond C and CH2 CS3. Okay, so these examples are on conversion. Okay, so we had a alkene, and on that alkene we actually added a ET group. Okay, this was the first example. On the second example we have something like a double bond. From a double bond we can actually create something like this. How can we actually do it? First, react it with Pr2 in presence of CCl4. Second, do 4 moles of NaNH2. Third, do 2 moles of CS3I. And how does this takes place? This is also an example of conversion in which we actually converted double bond into triple bond and substituted a CS3 on a triple bond. Okay, so let us see how this actually takes place. Okay, so mechanism would be something like when we reacted this with Br2, we will get something like Br here and CH2 Br here. When we reacted with NaNH2, regarding with 2 mole of NaNH2, we would get something like this. Okay, again we need 2 mole of NaNH2 to actually convert both this to actually extract uh, both these hydrogen atoms and create negative charge on carbon atom. So we need total 4 moles of NaNH2, 2 plus 2, 4. Okay, and after this is formed, we will convert this with 2 moles of CH3I to get CH3 on this carbon atom and on this carbon atom. Okay, so we'll get something like this as the final product. So again, in the last step, we needed 2 moles of CH3. Okay, so with this we come to an end of this lecture. In the next lectures we'll be seeing other 1-2 eliminations. So till then, good luck and goodbye.